Thanks, Paul. All right, so let's talk a little bit about security today. I'll introduce myself first. My name is Liran Tal. I'm a developer advocate at Snyk. I'm from Israel. At Snyk, we build developer tooling, developer security tooling to help developers and empower them to actually fix security vulnerabilities that they have in their open source projects. I am also actively involved in the Node.js security working group to help improve the state of security of Node.js and the NPM ecosystem as well, and through a lot of other projects like OWASP NodeGoat and some books I wrote about security. If you're interested in any of those and getting involved, I'll be happy to help, so just ping me on Twitter and we can take it offline. So, open source is awesome, right? We're all using, virtually everyone is using open source in one way or the other. It is a great way for us to go ahead and just focus on the business logic of things that we need to build and reuse what we can from the ecosystem. We can also go ahead and contribute back. Some of us even contribute and create and maintain projects, which is amazing. And I probably don't need to convince you that. You probably already know that. And as a testament of that, we have seen a lot of growth in all the NPM, all the package ecosystems of different languages, even Java, as it seems. I don't know, unfortunately or not, but generally, we've seen this growth going up through all of them. Actually, in just 2018, just last year, NPM has added 250K packages to the repository. Earlier this year, in June, we already crossed 1 million packages on NPM, which I probably don't need to tell you that, because all of you are pulling half the universe when you're done doing an NPM install. So really, the question is, how much do we know about the NPM dependencies that we're pulling into the project? Try to do a mental exercise just now yourselves. Try to imagine your package JSON, your package manifest. How many packages do you know, do you recognize those direct dependencies, and how many transitive dependencies do you also pull in? So there's a lot of dependencies, a lot of unknown that we are using in our projects and possibly involving some risks. An interesting article or a research paper that was actually published earlier this year that I had a chance to read and write about is something that actually compared the Python ecosystem with the NPM ecosystem. And it found that 61% of all NPM packages could be considered abandoned. Now, abandoned is a very open to interpretation. Different people have different opinions on it. For the sake of the research, what they did is considered any package that didn't have a release in the last 12 months as abandoned, which is arguable because you could just say that the package is well known, it's mature, it's reached its end state and goal. Except in 2018, some of us may remember the event stream incident. Probably the most sophisticated attack that we've seen on NPM happened to a package called event stream, which has been there for almost a decade, like 8 years, did not have any release for the last 2 or 3 years, depending how you count it. But someone was actually able to socially engineer their way into gaining NPM publish permissions to publish a module, injected a malicious package in the dependency tree of event stream itself, and in this way we're able to steal money from cryptocurrency wallets. So this actually happened. There's a whole postmortem on chain events if you're interested in following that as well. But also what that research paper actually highlighted is an important note about the dependency tree that we are always pulling in. So it actually found that on average, we'll be pulling in 4 NPM packages nested deep in every time we'll go ahead and install an NPM package. So this actually is very interesting in terms of how many packages are we pulling in and what do we know about those packages and all of those nested dependencies in the tree, what security vulnerabilities they may have. So as an example, and security vulnerabilities happen all the time, we just usually less hear about them as we're less conscious on this. But there we go with Yarn. Yarn is popular NPM package manager. It was found to be vulnerable to a man-in-the-middle attack. So for example, if you were here on the workshop or in a coffee shop, you were doing a Yarn install, someone could actually eavesdrop the connection and get the NPM tokens that you were sending off to NPM itself, because that was sent off on an insecure medium, so not on an HTTPS. So that's one, and I could probably do a safe estimation and guess that no one is using this latest version of Yarn that was just released a few months ago. Another example is Markdown, Markdown for JS6. This package is actually pretty popular. It's used for Storybook UI in several Gatsby teams, obviously in several Vue.js and React.js components as well. And it is also vulnerable to some XSS vulnerabilities, which were, again, only recently fixed. CLIs, another the most up-to-date example of an SQL injection, an SQL abstraction library that is usually popularly used on Node.js projects, actually was found to be vulnerable to several SQL injections and was just fixed last month. So if you know that one of your teams is using that, you should probably scan and make sure that you're fixing it and upgrading very quickly. Now, this means that a lot of open source is amazing and it's written by humans, but as we come to think about all of these risks, we come to also understand and realize that we do not know who wrote them and what is their proficiency, what is going on with those packages. For example, we actually conducted a state of open source security in February 2019, and we found a lot of interesting facts. For example, this one where maintainers would feel less confident in fixing security issues once they are disclosed because they do not think that they have a strong enough security knowledge to actually fix that and do something about it. Similar to that, for example, maintainers usually, or 26% of the time, will not audit their packages. They will not have any kind of security testing, not static application, dynamic application security testing, not even a security code review. So imagine your projects, all those dependencies, count 1 out of 4 that did not go any kind of security test. Now, that's pretty easy to do on a direct dependency, but just think about how all of those indirect dependencies that you're pulling in as well. So as we come to talk about the code that we have and how much we rely on open source, it's a simple app I built based on Vue.js and the UI framework called Bulma. So it doesn't have a lot of dependencies, but you can already see that what code is generated from my app and from the bundle of all the vendors that I'm actually dependent upon, it only represents 0.2% my code through the whole app. I think this is the most thing that struck lightning in terms of being able to understand and realize how much we're using open source, because this is a common misconception for me as a developer where I'm building code, pushing it to production, and this is my app, except my app is actually, it is that, but my code, what I write, my own responsibility is actually a very small piece of that whole thing. And when I'm pushing this whole thing, I'm pushing a lot of code into production, a lot of risk that other people would usually catch, such as DevOps and security engineers, and figure out that there's a lot of risk that I'm actually pushing in. So at this point, I guess some of us are wondering, we're talking about security vulnerabilities in open source libraries, and how much are we dependent upon? So how do we jump from a security vulnerability in a package, in a dependency that we're using, to a security vulnerability in our application that actually puts it into risk? So let's go ahead and go to the hands-on part of this presentation. So over here I have a simple Goof to-do application. You can do things like, I'm pretty nervous here, and it's basically a to-do app that I can just add some stuff into it. As a security-conscious developer, you might start already to think about how you could go ahead and attack this one. So it has an SQL injection input. Maybe I can do something around it. Maybe I can do an XSS. Several things, right? So maybe I would go ahead and add something like that. Maybe it works, maybe it doesn't work. Other thing that we should know about this is I've built this using Marked. So Marked, I'll go ahead and increase that so you can see. Marked is a fairly popular as well package for doing markdown. One example of understanding security and being aware of this is this is a bad example of it in terms of you need to opt in to security, right, to sanitize the data that's coming in when you use it. So it's not turned on by default. You actually need to know to do that. So as a developer, if you're reading this, you have to understand the APIs, read any security disclosure, and then turn it on. So we have Markdown, and I have Markdown support, so I can go ahead and do stuff. And I actually scan this up with Snyk, and I can see that I am vulnerable to cross-site scripting, right? And I'm part of 448 libraries that I have with. So again, what could I do next to go ahead and cause maybe an XSS as I've seen? How about if we try a different vector? We know that there is Markdown, so I can do like this and get something bold. But then I also have this vector of attack where I can add links. So imagine someone adding a JavaScript link into this. So maybe something like this. Right? And then we have links. So now I can go ahead and take this one step further. And perhaps I want to change this with something else. This is a good way to start. Except it doesn't work because Markdown is actually sanitizing it as we actually provided it. So it's doing something with the data, just we're not yet there. One thing that is common is to go ahead and represent data in a different way. So we can go ahead and say a colon on a web page could be represented by the HTML entity for that. So we could go ahead and do something like this, represent this as well, and do it. And the way that I know this, I do not need to reverse engineer something that is very difficult, because Markdown is open source. I can just go to the repository, figure out what sanitized true does, and just reverse engineer that. So it's pretty easy to figure this out. So I can do this. I can already see that something different is happening, so perhaps I'm on the right path. And at this point, again, I can go into Markdown source code and figure out why did this get sanitized in a different way. The truth is, the sanitization process in marked works this way, that it actually regexes this part of the string. So it actually looks for this kind of code and strips this out. So while I'm trying to be outsmarting it, it is actually someone as a developer there that wrote it was able to actually think about this vector as well. What they hadn't took into account is something that that happens in the browser, and that is, browsers are usually very nice in terms of they help us to, if we write like bad code, broken divs or forgotten divs or stuff like that, they would go ahead and complete that. So if I would just write something like this, like literally this, I know it's hard in JavaScript, bear with me. But if I put a valid JavaScript statement like this as a keyword, it will go ahead and pass the sanitization process by marked, because marked does not look for this. It looks for a specific string as someone trying to hack this out. So when I do this, I get this link actually working. And what the browser does is it says, well, I think you meant to end that 58 character with a semicolon, so let me do that for you. It adds it, and because this is a valid JavaScript statement, the whole thing gets validated as valid as well, and we have an XSS in our application. So one example of that is this. We can go ahead and figure out some other examples. For example, I have this about page, which is based on, so this is, I'm not doing anything dynamically. I'm actually using a template engine for Node.js called Dust.js, developed by LinkedIn for a framework called Kraken. It's actually a pretty secure project, etc., but a bit of an oldie reference here. Anyway, what I have is an about page on this app. And you can see how I'm like really great at CSS, because I have this skill to make it big, make it big. All right, so let's go back to this. So it is a mobile-first application. You can see it actually responds reactively to what I do. And at this point, again, I'm trying to figure out what can I do with Dust as a templating engine on this application. So give you a bit more context into what's going on. This is a template for it, right? About new, it has the Dust extension. I have this condition where if something is a device equals a desktop or mobile, it's going to run through one of those branching statements in my conditions and draw the HTML for this. So pretty straightforward, but the question is what we can do with this. If we were to figure out what is Dust vulnerable for, if you would scan your app, you could scan it with whatever you want, Snyk or npm audit or OWASP dependency check, doesn't really matter, but you would find something like this, like Dust is vulnerable to a code injection. What does it mean, a code injection? How does that really happen? How does that impact from a library to my own application? So the thing is, there's a user input here, so we can go ahead and start and doing something with it. And for example, I can go ahead and put maybe a quote, because maybe I'm trying to escape this whole quote condition and do something with this part of the code. Maybe I would do something like this, except that seems to be OK. Dust is probably behind the scenes, encoding it, doing it properly, etc. And we can actually see that Dust has this escape HTML part of the code. So it's actually taking a string, trying to see if there's anything malicious that should be encoded, something dangerous that should go through encoding, and then it's going to go and encode it. So it's going to replace it with the HTML entity for it, and this way try and not use the original quote or whatever parameter I was trying to do to circumvent the app. This is great, except it is actually only going into this safe condition when I'm giving it a string. At this point, it's really interesting to figure out how do I hack through that and do not give it a string because I need to put something else, but to bypass this part, which is not a string. So one way to do that is to think about array parameters. So the way that you could go ahead and do a request poisoning like this with an HTTP parameter pollution, and you would say desktop is now actually an array. This is very common where you have like end user ID equals something, end user ID equals something, and you want to pass an array to a request parameter, or you can also use the brackets notation to go ahead and convey the same intent. As you can see when I'm doing that, this continues to work just fine, because when the evaluation happens over here, I'm just going ahead and doing a toString for an array. That's going to give me the first item under. So it seems that the app is actually working well. But what's interesting is if I go ahead and try to put a quoter, something fails. And we can already see what's going on. So to understand a little bit better what is actually going on behind the hood with this security issue is this if condition is actually something that gets evaluated through runtime, because this is generally how the template engines work. And Dust has this helper where for ifs, it's going to go take that condition and evaluates it. So knowing this, I can go ahead and figure out, well, if that condition works, maybe I can provide a specific string to do something. Let's try to run a commander. So I'm going to add a request. From the CLI, so we can do this together. And I'm going to go and see that everything is OK. I will add a quote, see that everything is OK again. I'm going to go and add this to do the whole thing and reproduce the whole bag. And now I have a working example that I can actually work with. And this is where the fun begins, right? Because we know it's an evaluation statement. So it is as simple for me as doing something like, node, and then evaluating desktop equals desktop, for example. It's going to be true. But now that I know that I have a way to inject data there that is not being treated in any other safe way, I can go ahead and do something like this, which is trying to evaluate an expression for a place that expects a value. So as I do this, I don't really care about whether that's false or true. I care about the fact that I was actually able to invoke a function through this eval statement. So going back to our request, I can do something similar. And I will make this a bit bigger. So you can see I was able to go ahead and put on the server side a function expression, right? A function invocation that actually did a console log. So remotely a code injection. Now this is just for the example, right? Just for us to be very fast in this example in the demo. But imagine what I could do here. Just require process, child process, invoke something that I want to get from your application or anything else. All of this is done through Dust. If this page was not even authorized, anonymous, it means everyone are able to do this. So it's kind of a remote code injection. So we're talking about all of these examples with open source libraries and how much they affect us and what's the risk that we have in them. And the thing is, for attackers, that's a really easy way to do it, because it's easy to think about attackers and hackers as those with their hoodies, wearing that, trying to hack the Pentagon or something else. But mostly, like the low-hanging fruits, the easy stuff that they can do is just figure out all of those known public vulnerabilities that everyone know about. It's publicly known, but people are really late in terms of patching and keeping up to date with them. So one vulnerability that they find in an ecosystem like NPM, for example, will mean many victims, because everyone are using open source. Millions of downloads for Express, Angular, React, whatever vulnerability that they find. And AppSec is pretty hard, right? That's one example of it. And there's so many things that need to happen in a secure application development lifecycle. Just one example. But what's really challenging is software delivery has sped up. It is really fast. Everyone trying to be really mature in terms of CI/CD, pushing value, pushing data out, pushing code out, etc. But do we forget, do we actually embed security testing in part of our applications, in what we develop and what we push out? Do we have this confidence that everything we push out is really tested very well and does not have any kind of security vulnerabilities like this? We're also outnumbered in organizations, right? In organizations, the ratio that like Gartner report was saying is 1 security person for 100 developers. That's actually a good example of it, because in most organizations, it's actually pretty worse than that. How about the fact that as developers, we do not really get any knowledge or any practical experience or expertise on security? For example, these are the top computer science programs in the United States of America. I imagine that you're able to recognize some of them. I filtered that list to show all those that actually have a requirement for a software security course. Yep. So no wonder that, as developers, we sometimes feel that we do not have that knowledge and that gap that exists for us to build applications that are secure. How equipped do we feel in terms of not just finding, but actually fixing a vulnerability, actually being able to remediate it? But because at the end of the day, it is our responsibility. And it's great that it is like that. Open source is awesome. We just need to do it in a very good way. It is not so easy to fix a vulnerability. And another thing that we learned from that State of Open Source Security report is, as we looked at the data that Snyk has on all of its users, we just scan package manifest files, so we really care just about the dependency that you're using. And what we try to plot out is, how does that work in terms of different ecosystems? Like, where do we find security vulnerabilities? So for NPM, for example, you can see that 78% of the time, we will find security vulnerabilities in transitive dependencies. So even if you're like a conscious developer, and very responsible, and you track all the change logs for React, Vue, whatever it is, and you go through each code change one by one, most of the time we'll find the issues in the vulnerabilities that those dependencies pull in, and the problems that exist there. So what if security was a bit easier, right? What if it was something that is actionable, that is really friendly for me to interact with, that as a developer it is aligned with the way that I work. It's not a security system that I need to log into and find out about a lot of these things. What if, for example, the same way that you have a Travis or a Circle CI or code coverage running in your pull request, you would have another test, and you can replace Snyk here with anything else that you want generally. But what if you add that, right? What if a new developer was now introducing a package that has security vulnerabilities, whether on it or its transitive dependency, you would go ahead and fail the build because you already detected it right there. You do not need to find it as you go to production and find it a few months later. What if that security tooling was really, really good in terms of not just opening a pull request for you and fixing it, which is a great step in doing that, but also doing that in a smart way. So in terms of if a dependency had a vulnerability, and then a fix in a major version, it will actually try and pull the most minor and minimal version it can to resolve the security fix. So to not get you through the hurdle of actually taking in a major change or breaking change or feature changes that you may not want to pull in with that security fix. So I'm going to leave you with that notion. Open source is awesome. Just please join it responsibly. Thank you.